What's up, guys? In this video, we're going to make the distinction between a rigid and a non-rigid motion. Letter A is an example of a rigid motion. Anytime you're adding or subtracting from your x value and your y value, you've got a rigid motion. And let's have it see, what does that look like? Take this point right here. It is 2, 2. Well, the y value is going to stay the same, but the x value is going to get 3 added to it. 2 plus 3 is 5, so that should give us a point right there. And same thing here, 2 plus 3 is 5, but the y value stays the same. And at this point, maybe you can just recreate the shape. The x coordinate here is 5 from the point 5, 2. So 5 plus 3 is 8. And similarly for this point up here, this is called a rigid motion because the point, the shape has moved over, and there's not much more to it than that. The shape has just moved left, right, up, down. In this case, it just moved to the right 3 spaces. So that's called a rigid motion. And letter B, this is an example of a non-rigid motion because we have this smooth and continuous change when you multiply by a factor of 2. As I'm sure you recall from 8th grade math, this is a dilation. Anytime you're multiplying or dividing the x term, you are dilating. So here we have the point 1, 2. So we're going to multiply the x value. Let's write it up here. 1, 2. The x value gets multiplied by 2. The y value gets multiplied by 2. So our new point is 2, 4. So that's over 2 and up 4. And same thing here for this point up top. It was 1, 5, now multiplied by 2, and it is 2, 10. And it's up here, going to overlap on my point here. So let's get that out of there. Here and here. And then this point is 3, 5. Multiply both of those by 2, and you get 6, 10. And this point down here will fit the pattern. Multiply by 2, and you get 6, 4. And then we can connect the dots here. That is a non-rigid motion. And maybe the telltale sign of rigid or not rigid is did the shape stay the same? Do we have the same size and same shape? Is there congruence maintained from one to the next? In this case of the rigid motion, congruence is maintained. And in this case down here of the non-rigid motion, congruence is not maintained. So rigid motions are just moving the shape around. They maintain congruence. Non-rigid motions are more like dilations, and they do not maintain congruence.